Hello and welcome to As We May Think. In this video, I wanted to talk about storage because storage is basically something you need for any side project that you're likely to do. You're going to need a way to store some data away, have it be persisted so that your server could shut down or could crash or whatever. You could bring it back up and all that data will still be there. Just keeping it in memory is not going to cut it for that. So there's a whole class of embedded databases that are out there that you can use as part of your node code. So if you have a node.js server and you need to store data, there's not like one choice available. There's like a dozen or more choices available for you to store data. One of those that I've used in the past is this one. It's called NeDB. And if you watched my last ScorePad video, I actually used this database in it just a little bit to demonstrate some persistence. Its claim to fame is that it is designed to look a lot like MongoDB. It has a subset of the API that MongoDB has, and MongoDB is a fairly popular database, especially with JavaScript projects, because it's a document-based system, as opposed to, say, a relational database system. In relational databases, you have tables filled with rows of data, and then those rows of data have relationships to other tables full of rows of data. That is a really common model for databases, and you often use a language called SQL or SQL to make queries against those and insert data into them and pull data out of them, and etc. Document type databases like MongoDB are pretty different in that they look a lot like JSON. They look like a lot like what you're used to from JavaScript objects already. They have members, and you can keep adding members onto them and making objects within objects that have relationships to other bits of data, arrays of data on them. In other words, there's a really nice mapping between what you're used to in your JavaScript code and what you can do in document databases like Mongo. So the fact that NeDB is an embeddable database, basically all you have to do is load this module into your software and then start using it. You don't have to set up a server somewhere else and make a connection to it and maybe set up clusters and all kinds of stuff like that. If you can avoid all that, it gives you a really fast solution to get up and running for a new side project, which is exactly why I think it's a good choice. That and the fact that it looks a lot like MongoDB gives you a migration path to then later on take the code that you wrote and make a few changes to it and move it to a more sophisticated system. So if your side project starts to take off, you can say, well, now I've got a natural growth path to take this code and move it to MongoDB later. Because if you look at this code, anybody who works on MongoDB would immediately recognize this as, well, that's pretty much how you do MongoDB these days. There are some differences, and one of them you'll actually see in my code. I'm using db.insert because that's compatible with NeDB. However, if you look at Mongo these days, it's actually insert one or insert many. There are several different variations of that, so they aren't one-to-one compatible. And the reason for that is because NeDB, although it is pretty solid and has, doesn't have a lot of bugs, it's in good shape, it really hasn't gotten any love in quite a long time. This one small update here a year ago is the exception. Pretty much everything else hasn't been touched in several years. So I really objected to that some weeks back on another project, but here I'm saying it's okay, and the reason I'm saying it's okay is really because I don't anticipate you're going to stay with this for a really long time. It's just something to get your project up and going very, very quickly. And then later on, if you have any luck with it, then move it to something better like Mongo. So we'll talk about that some more, because what I did, and let's hopefully I haven't completely lost the track on all this, because it's going to seem complicated and weird. But the idea was, so I built this project that you see here. I just called it storage, but it's not just storage, it's an authentication system. It's a very, very minimal authentication system. It basically has sign up and login. And those are the only two functions it really offers to you, so that you can plug this in to a side project, and it will use NeDB to store the user accounts as people create them, and then allow them to log in again. I added a little bit more to it and a little bit more to it, but there are specific areas that I had on here that I took off. For example, I had a way to delete an account, and I took that off. And I also had a whole profile system I was starting to layer on top of this, and I took that off as well. I felt all of that kind of obscured the basics of what I was trying to convey, and it's something I can come back to later as we decide to build on this and actually put it to use. Specifically, what I've done is I've taken this authentication system. I'm going to show it to you built with NeDB and MongoDB. Those are probably going to be two separate episodes. The first one's just going to be the NeDB one. Then I'm going to talk a little bit about why I'm not quite as sold on that as I was at the beginning of the idea of this project. I'm going to show you another alternative that I also built, and then I'm actually going to show you in another video me trying to use this authentication library to see that it actually works and make changes to it. And I haven't had to make that many changes, but anyway, let's get started a little bit, and I think some of this will be a little bit clearer. So before I do any work with NeDB, I wanted to talk about a tool that I'm going to be using. It's called Insomnia. And Insomnia is just, there are quite a few tools like this one around. I happen to like this particular one. It's a good Mac-friendly tool, but I believe it's also available for other platforms as well. It's one of those tools where you can set up a whole bunch of different gets and posts and whatnot, just API queries where you're going to want to try out an API, set up different circumstances, and then make calls. So at the moment, let's go ahead and start up the server, actually it looks like it's already running here. I forgot I started earlier. The server is currently running, and it's using NeDB for its storage, which in this case, it's created a small file called users.db down here, which should be, looks like it's empty. So we're good on that. So don't have to mess with that right now. Now we're going to actually test out making some calls to the server. And as I said, some of this won't be covered until much later, but I wanted to give you an idea of how this would work. So I'm making a call to an endpoint called /API/login. It's a post, and I'm passing the email and the password. So we'll do that. And it says unauthorized. That's because there is no account named John Munch yet. So we will actually create one with this sign in, or it really should say sign up. And there we go. So that now has created an account, and then we got the response back. And that gives back what's known as a JSON Web Token, JWT. It's often called a JOT, but it's basically a token with a bunch of data in it. So actually, if we go over to t.io, this is a site devoted to the whole idea of JSON Web Tokens. Trust me, some people do not like these, but I'm not a hater. I have some good reasons why I do and don't like it, and we'll talk about those later on. But I'm going to paste this one in. And as you can see, this token that I received back from the server has multiple sections in it. They're separated by these little periods that you see. And they have a header that basically says how this particular JSON Web Token was encoded. And they also include the following information. This is called the payload. And this set of data is data that I put into the JSON Web Token so that it could be stored. So it has an ID. You'll see where those come from in a minute. The email of the user. That was the one I used when I tried to sign up for an account. And basically a point at which this was issued. So it's an issued at time. You can add other bits and pieces to your payload, make it have all the different parts that you need, and you can even sign it with a secret key, so that signature comes to the front side, and the user can validate that you are the one who sent it. They don't really care about that, so you're not likely to do that much. But, on the other hand, when they send this token back to you with another API call, you can confirm, I signed this. The user has not modified it. It's still exactly the same JSON Web Token that I sent to them. So all the data in it can be trusted. Why do you care about that? Well, you've probably, if you've ever built APIs at all with JavaScript, then you may have used cookies for this kind of thing. You may have said, I'm going to have a cookie that I send to the front end, and every time they make an API call, I get that same cookie back, and that helps me authenticate who the user is. JSON Web Tokens perform the same function, except that they're usually sent a slightly different way. And even if you had a bunch of different servers on the backside that were all handling your API requests, every one of them could individually decode this, and they would all be able to see that it was a valid token and that the API request was a valid one potentially. You would not have to go over to a database to go look up their account, pull back information, do any other kind of validation. Just the token itself is self-validating because you signed it. And so as long as all those back-end services have the secret, they can decode it in a fraction of a second, confirm that it came from you in the first place, and that it's just the user sending it back to you, and that it's a useful token. I'm going to use those as part of this authentication mechanism. So when I do logins, you'll get one. When you do a sign-up, you'll get one as well. So let's see. Here's an example of a function call where we're actually passing that token. It's the same token we generated a minute ago. And it's got the it simply says authorization, bearer, and then that token is part of the header that's going to go up to the server. So I'm going to call an endpoint that if I didn't have this, then it would fail, because this is how the backend is going to confirm that it's okay for me to call this particular endpoint. So first let's try it with no JSON Web Token being sent. So if I try this same endpoint with no JSON Web Token, I get unauthorized. That's what you'd want. If I send one where I've kind of mangled this a little bit, removed a few characters out of it so it no longer validates the way it should, the signature is still fine, but the data itself has altered. So I try and send that. That's still also unauthorized. But if I come in here and I do the same thing and I send it the valid token, which only the end user who has, logged in or signed in has, then I get unauthenticated. So it successfully says, oh yeah, you're fine. You can go to this endpoint and I'll send you something back. So that works just the way we want it to. Okay. Let's do, we haven't done I don't think we did a login, but just in case, we'll go ahead and do a login for that same account we signed up for earlier. And as you can see, we get a token back, we get the information about the user, as well as some additional information as well. All right, so this is what we're going to build much later. Probably not the next video, but the video after that. But the stuff that lies underneath this, the part that actually handles the sign up and handles the login, we're going to start talking about that immediately. And the mechanism I'm going to use to actually build this is a good one in general. So if you have to build APIs, a good place for you to start from is unit tests. Okay? If you need to build an API, you may have heard the term TDD before, or test-driven development. The idea is that you write a test first, and then you write the code that makes the test work after you've written the test. And that seems counterintuitive, but it actually makes a lot of sense because it makes you focus on the idea of, is this a good UI? Not a good UI. It makes you focus on the idea, is this a good API that I am building on the back end? Because you're shaping the API to actually using the API. So let's look at this in practice. Mocha is the tool that I'm using both to run my tests, and also it provides a framework for the tests themselves. So let's look at the tests that I wrote for this. Now, I've altered these several times. So if you go back and look through the GitHub repo and look at all the commits, you're going to see a lot of changes to this. But this is the kind of the final version of it. And it pulls in chai. And Mocha is not necessary, doesn't have to be pulled in directly because Mocha is actually running the tests. So Mocha is just kind of in the environment whenever we run it. So what does that give us? It gives us this framework here, which is basically describe, where a describe is a grouping of tests. So you're saying describe, and then this name authentication groups together a bunch of tests. Ignore before and after just for the moment. So now it boils down to all these it statements. Each one of these its represents a single test by itself. So there's a describe, and then these should kind of make sense as an English sentence. So in this case, it says authentication, it will fail on a login for a non-existent user plus password. That's what the first test does. Then the next one says will fail on a login for a non-existent user and no password. It will allow a user to sign up and then immediately log in. That's another test. It will fail for a sign up and then log in with the right user but wrong password or no password. And then finally, the fifth test that I wrote was will allow sign up and log in, and the return token will validate fully. These are the 5 tests that I wrote, and I really wrote them kind of like you see here. I wrote them simply saying, here's the describe, and I put the name in, and then I wrote a series of tests basically just saying it, and then the name of the test, and then a function to be called. Inside the functions, and this is generally a good way to start this off, you write a new test. Let's say it will be a new test. So that is the framework for writing a new test. You would put some descriptive thing that describes what the test is, what it does, etc. Obviously that's not a good description, but you get the idea. And then you come in here and you should make your test fail right away. So I'm going to put in some code that will do that. Assert fail. Now where did assert come from? Mocha is being paired in this case with another library called chai. Chai is about assertions. It goes together with Mocha. Mocha provides that framework of describes and its, and you can even nest describes, so you can have groupings within groupings. So you might have an outer describe that had one name, and then you might have 2 describes inside it that were groupings of maybe 5 tests and 3 tests that go together. You can even have your tests spread across many, many different files. So Mocha will handle all those circumstances for you. And Mocha can also be used not just for these node.js tests like I'm doing right here. They can also be used as part of another tool. There's a tool called Karma, which will load up your Mocha tests inside a browser. And then you load up your other code that it needs to test with it. And you could use that to test your components. And we will doubtless see that in a future episode where I demonstrate how you would use some of these very same tools. You would use Mocha again, you would use Chai again. The only bit that would be different would be the karma. And the karma is just responsible for setting up the browser and loading all these bits into it. And you could use that to test your lit element components or any web component. It doesn't have to be lit element at all. It could be just any kind of web component. You could load them up and confirm that your component was working, and you've reused all your knowledge about how to build tests with Mocha and Chai, etc., to build those tests as well. So you didn't have to relearn a whole new framework to do that stuff, which is why I picked them for this example as well, because these particular bits work just fine for the node tests that I wanted to do here. So Chai is the bit that we use to do different kinds of expectations, because no test really works unless there is an expectation. You set something up, you basically say what you're going to test, that's what the name of the test is. Then you set things up, you perform some action, and then you have some expectations that are true. Like, I loaded up this library, I ran this function, now these things should be true. I should have gotten this output, this should have happened, an error should have been thrown. Whatever the case is, that's what Chai helps you with. So we're using Chai in this case. I did a require right here, and then here is where I'm getting the expect version of Chai, which is what I used in most of my tests. And then I also pulled in assert, because assert had a nice fail function on it. So I've made a new test and I've immediately made it fail. So we'll test that real quick here. We're going to put X in front of each of these tests, which tells it not to run those tests. And I don't think we need the server running anymore, so because we're not going to be demonstrating that today. That is for a later video. So now if we do npm test Mocha ran, you saw the word authentication here. This is the grouping, and then here are all those names of those tests, right? And then right here you see that this one failed. There was an assertion failed in the test. That caused it to not be okay. So now we know that the failed test is oops, I left one of those tests running. There we go. Let's try that again, because we shouldn't have any running. We should have had 5 not running at all, because we put an X in front of them. You can also put X in front of describe and disable like whole sections of tests, but we're not doing that in this case. And then we run this again, one more time, sorry. All right, so now we have 5 pending tests. That's what we did. We disabled them all with X, and then 1 test that's actually running, and that test is failing. So with that done, you would now come back in here and you would write some code to some setup code, some kind of action, and some expectations. That would make for a complete test. Sometimes you won't have much setup. Sometimes the actions themselves will be all you need to do. You might do an action 1 and an action 2, and then that will be sufficient to make everything be testable. Let's actually look at some of these tests, and then I remember again, I wrote these, and then that helped me figure out exactly what I wanted the API itself to look like. So the first test that I wrote was this one. And I said, okay, let me write a test that says, if I have this authentication object, I want to be able to call login on it. And if I give it somebody's name and their password, their email address and their password, then it will fail if that person isn't actually in the database. And so what I did was I said, okay, I'm going to put try and catch around this. If I'm going to consider it a failure if I get to this point, because what I really want it to do is throw an exception, and then we'll catch the exception. That is actually success. If it throws an exception, that's what we want. So if it continues on to the next line, that's the failure in this case. So that was the first test I wrote. And that told me, okay, I want to make sure that whatever authentication library I write, it's got to log in. I also came up with this stuff a little bit later and added on. I want it to return a user. I want it to return a token. I could have left that off here knowing that this should fail, but for the moment, I left it like that. The next test I wrote, same kind of idea. In this case, I tried a login with a username and no password, or an empty password, effectively, the wrong password. And again, that should fail if no error occurs. And it should actually be okay if an error occurs. So I wanted to, for all these, this returns a promise, actually, because it could take a little while for this to get authenticated. So in any of these cases, there's a promise behind this. And so here I used async and await, and for my next example, I didn't use async and await. I just simply used then and did the promises. So I also was trying out the different ways of using promises and making sure that all of them worked in my tests. Here's another example. I kept it in the same test. It basically says, I'm going to log in. I'm not even going to supply anything, not even an empty string for the password. Still want to get the same kind of result. Fail if no error was thrown. If an error got thrown, that's great. That's actually what I want to have happen. So let's re-enable this one. So for the third test, it was a more basic happy path, sign up and log in. Create a user, username, password, then log in immediately with that user. We should get a user back as well as a JWT token, or JSON web token. And let's see. And then we're going to verify via expectations that the token is not undefined, the user is not undefined, and that the user has an underscore ID on it. None of these things will be missing. So that's the only way this test passes. And then I follow up with some more failure type scenarios. In this case, I create a user, but then once they're created, I try to log in with the wrong password. So this is kind of like the first one, except that in the first case, in the first test, the user didn't even exist. So this is a different scenario. Tests again, make sure that it gets failures in the right spots, which is, of course, it shouldn't succeed at logging in. And then I try the same thing again with an empty password. And that also should fail. Okay, those are all my initial tests. And then finally, one last test. Let's make sure that one's re-enabled again, because we're actually going to run all these tests. And actually running these tests and seeing them fail at first, and then coming in and writing some more code and seeing them succeed and seeing them succeed and seeing them succeed, that's how I actually wrote the code that you're about to see in a minute. Or actually, we may take a quick sojourn to look at NeDB code, and then we'll look at the code I wrote real fast. So this is the last of the tests. It does a sign up, and then it does a login. This ideally should succeed. Everything should be good. And then it gets a token back, and I actually use a piece of code on JWT decode. It's kind of similar to what you saw on jwt.io. It decodes that token into its various parts. It pulls out specifically the payload portion of it, and then it says, hey, did the payload have an underscore ID on it? Did it have an email? Did it have an IAT, when it was created effectively? And it's only okay if all those things actually existed. And so this complete set of code, if we run it, and actually that caused, we did get an error there because of a duplicate key. That's, I'm working on some tweaks to this to where it doesn't freak out if there are duplicate keys. But let me go ahead and remove that real quick, and then we'll try this again. You'll see it should work this time. And it didn't. Not sure why that gave us an error. Alas. Oh, I'm going against the wrong database. Sorry. You got a preview of later stuff. My apologies. Let's try it again. This should work. Perfect. So actually, you caught the fact that what I was going to tell you later is that I actually have several versions of this implemented. I have a NeDB version and a MongoDB version, and actually another version called TingoDB, all of which have basically the same library. They all kind of try to look more or less like MongoDB. Obviously, MongoDB looks like MongoDB, but the other two try to look to varying degrees like MongoDB's interface so that the code doesn't have to change significantly between them. So these three different versions can actually be swapped out, and the rest of the code doesn't care. That was the shocking finale to all this. Anyway, so let's actually look at the NeDB version of things, and let's take a quick side trip to example code from NeDB. All right, so the author gives several different ways to create NeDB databases. You can just use it entirely for in-memory. Obviously, most of the time you're going to want persistence, so you're going to want to save it out to a file, and you give it a file name, and it's able to store. And then you're going to do commands like db.insert. Again, looks very much like what MongoDB would do. Creates a record, a document in this case, and again, like I said, you should recognize this as looking like just any other JSON object, right? I mean, it's got arrays in it, it's got objects inside objects, it's got all your basic values like strings, numbers, booleans, null, undefined. The undefined doesn't get saved, but all the other things will get saved to the database. And you can insert even multiple objects at one time. You can come back and you can find objects. There is, in MongoDB, if you've never worked with it, it has a whole query language that is in the form of a JSON object. You create this query, and then you can query the database with this JSON object, and it will return a subset of information to you. That is supported by NeDB as well. So you can say, I'm interested in finding the ones where system is equal to solar, or finding like a regular expression within it, or all these different kinds of things. And you can actually go deep into the object for a match. We make use of these kinds of things. I'm not going to belabor this and try to go through the whole thing. Again, learning about MongoDB itself or learning about NeDB, all that information is going to overlap. So that's why I think it's kind of worth picking something like this. One of the things that I love about JavaScript is that JavaScript these days is the only place you can go that is a one-stop shop. If you need to do database work, you can use it for database work. If you needed to use it for back-of-house stuff, if you needed to build a server, Node works really well. If you needed to build front-end code, well, honestly, there aren't any other choices for front-end code. It's JavaScript, and pretty much just JavaScript. Sure, WebAssembly will someday allow a lot of languages probably to cross-compile their language code into JavaScript and then run it on the front end. So in that sense, JavaScript will someday be kind of like the Java VM. The JVM gets used as a runtime engine for other languages. JavaScript will be used via WebAssembly the same way for people who don't necessarily want to use JavaScript. That's fine. But today, JavaScript is a great choice for front of house in the browser, back of house in Node, even your database work with a database like a MongoDB. Likewise, if you use MongoDB or something like it, you can potentially use it for a quickie side project as something embedded with one of these databases like NeDB, and then later on migrate most of that exact same knowledge over to MongoDB, and it will work even better over there. That's the idea behind what I wanted to talk about today. So let's look at the NeDB code that is specific to NeDB. So let me, and by the way, I don't know for a fact that it's pronounced NeDB. It's obviously spelled this way, and I'm assuming it's a cute pun on NeDB. That's my guess. But for all I know, it's called NeDB. I've got no idea. Doesn't really matter. I'm calling it NeDB. So this is the only code that is actually unique to NeDB. I'm taking most of the code from an authentication library. We'll look at that in a minute. And then the rest is an init function, which basically does what you saw a minute ago. It starts up a database and a collection for NeDB, so that data gets stored into this users.db file that you saw appear when I ran the test. It ensures an index so that email cannot be repeated, and by saying that field has to be unique across all the users. And then finally, this doesn't actually get run during the normal code. I use it only for the test code, and this is actually designed to go ahead and delete the file after it's done running. In reality, when you're running in the test code, it tries to pass in a different file name. All this portion of it needs some tweaking, so you might see slightly different code in this area when you actually pull the code. But the tests plus this code, that got me an up and running NeDB version of things. Now the authentication code, which is the last bit that we're actually going to go through today. In the next video, we'll talk all about MongoDB and also TingoDB, and we'll talk about how they've differed, and then we'll actually see a few other things that I wanted to talk about with embedded databases. But this next part is the meat and potatoes of the actual authentication, and this code works with all three databases. It is a class, again, and there's a signup function and a login function. The rest of this you can ignore for the moment. This bit of code you'll see in the third video when I actually try and put this to use in an Express server. So the two parts that we really want to talk about are signup and login. Signup, okay, so you might not have ever built a login system. And if you haven't, that's fine. This is a fairly minimal one, but it's not ultra minimal, in the sense that if you store your passwords in plain text in the database, like if I could just look at the database, whatever database you're running, and it says password, and then here I'm seeing everybody's password, that's a really bad thing, because it means that somebody can steal that database and I have everybody's password for the entire website. And what's even worse is not only that, I probably have their password for a whole bunch of other sites, because people have a really bad tendency to reuse their passwords a bunch. And that sucks. So what you really want is you want to encrypt the passwords when you store them. And bcrypt is an excellent choice for that, because what it does is it does multiple iterations of a really complex calculation to encrypt the password and then give you the encrypted password. This takes a long time. We're talking several milliseconds, maybe 100 milliseconds, 50 milliseconds, I don't even know, but it's quite a bit. And it does that by churning through the same password over and over again through a complex operation. Why do we do that? Because if somebody then wanted to turn around and run a bunch of common passwords through to see if they could match the passwords that you've got stored, they would have to use bcrypt as well, and they would have to run a lot of iterations, so it would take them many, many milliseconds for each and every try. So that makes their brute force attempts to break your passwords much harder. The other thing it does is a thing called salting. Let's see if we can see. I think here, let me rerun this again because I want to actually show you something here about the passwords themselves. Where did it store the passwords? All right. So I want to show you something about the passwords themselves and how they're getting stored. All right. Oh, I know what the problem is. It's deleting it as soon as it ends up running. So let me prevent the deletion real quick. So let's see if we can do the X after. Does that not actually work? Ah, I never knew that. Okay. We'll disable this a different way. Okay, so now it left that file sitting around so that we can look at it. And the reason why I wanted to look at it is see how this password is got all this encryption on it? I think the password for everybody is fairly short in my examples, but there's this huge mass of stuff. That's what bcrypt did, but it did something else as well. One of these two values, I'm not sure which one. I think it's the one on the end, but it might be the one on the front. It doesn't matter. One of these bits is what's known as salt. It's a random value that got stuck onto the password before it got run through bcrypt a bunch of times. The point of that is people are so lazy that they'll use the same passwords that everybody else is using. There are tons of people who, believe it or not, will use the word password as their password. So if I used a regular encryption, didn't matter how many times I encrypted something or how complex it was, if your password was password and my password was password, then when I looked at the table, I would see the same encrypted value for you and for me. So that's an obvious security hole, because what it tells me is that if I can decrypt one of those passwords, I now have what the actual password is for all of those people that had that same one. And furthermore, it might even tell me, if I see it really often, to try one of 2 or 3 really common passwords, or one of 20 or 30 really common passwords, because I know it's almost sure to be one of those. With salt in there, even though you and I both picked password, the salt was random for you and the salt was random for me before it got run through bcrypt a bunch of times. And as a result, they look like absolute nonsense for both you and for me. So the final result for you and me doesn't look like password in both of those two cases. And that's another thing you get from bcrypt. So, those two things, they don't seem like a lot, but they are pretty basic stuff. And you got them for just adding this one thing. And I think it's well worth it. So I now have a encrypted password, and I can do an insert of email, password with the encrypted password, a creation date, and then a profile, which by default is an empty object. But you could pass something else if you wanted to. I have not built a complex profile system on this, but there's just a basic provision for one. So like if you needed a user name, for example, you could provide an object with name and then the user's name in here. Once this has succeeded or failed, we get the new user back, it creates a JSON web token. It signs it using the secret, which you saw here. I was using this random string. Note, I'm not using this for any real sites. This was strictly for the demonstration, so you're not getting any amazing secrets here. And as far as this goes, I will be destroying this account at some point in the near future, so that doesn't really get you anything either. But anyway, that is how I connect to the Mongo database. This enables us to have a this is the payload of the JSON web token right here. Here's the payload. Here is the secret it ends up getting signed with. That's how we verify it when we see it again later. And then finally, I send it back as the answer to the promise. So that goes back to whoever called this function. Login is very, very similar. It's simply doing a find inside the database using the email. It finds that user. If it didn't find any user with that email, hey, it knows that that was a failure and it rejects the request. If it did find a user, it does a bcrypt compare, which is, like the crypting thing. It basically says, okay, give me the password that is they supplied as their password, and I will crypt the heck out of this using the user password. So it pulls the salt out of this, puts the two together, and then it runs this through a bunch of iterations and says, oh, did they match? And if they do, it says, oh, no, those are fine. Those match perfectly. Or no, they don't They don't match, then I know something is wrong. If they match, it creates a new token just like above. In fact, I should really pull that into a function so that it's not repeated. And then it resolves that. That is the sign up and the login. In how many lines of code is that? Was it from line 12 to line 66? That's it. That's all it needs. And yet, that's not a terribly insecure method. This is a fairly reasonable, solid method of a basic authentication mechanism for your app. This works perfectly well with NeDB. You saw it pass all the tests. And in the next video, I'm going to come back to this again. I'm going to show you the Mongo code. I'm going to show you how it differs. It's not going to be phenomenal. I'm going to talk about ways you can learn some more about MongoDB, which is going to help you not just for MongoDB, but also for NeDB. And I do want to emphasize just what was required for the NeDB version of this. For the NeDB version of this, that was it. We installed the package with npm install NeDB, and then I did a require to pull in the data. That's all it required. So there was no big database setup. I didn't have to get servers or get accounts somewhere, make sure that there was some other server set up. None of that was necessary. This was sufficient to get the server, to get me a storage mechanism. That's why I think you need, in your bag of tricks, a simple, fast mechanism for storage that you can just reach in and pull out. And NeDB is not a bad one. In the next video, I'll talk about MongoDB. And the video after that, what we're going to do is we're going to use this authentication stuff, and we're going to use it in an actual Express app. Thank you so much for listening again to As We May Think. I appreciate your viewership every single time, and if you enjoyed it, please click like and subscribe, as well as the notify bell that you see on your screen. That'll let you know whenever a new episode drops, which is normally Tuesdays and Thursdays. Again, thank you so much. Bye-bye.